Dear students, welcome to the next lecture of Inorganic Chemistry. In this lecture, we shall discuss about the hydride of nitrogen, that is ammonia. Ammonia is otherwise known as nitrogen trihydride or azane. It is a colorless gas with a characteristic pungent smell. Ammonia can be prepared by heating ammonium salt with a strong base. For example, ammonium chloride when treated with calcium hydroxide gives ammonia, calcium chloride and water. Similarly, ammonium sulfate when treated with sodium hydroxide yields ammonia, sodium sulfate and water. Ammonia can also be prepared by the action of water on metallic nitrides. The nitrides of magnesium, aluminium, calcium, etc. gives ammonia and the corresponding metal hydroxide. The ammonia thus obtained is dried using calcium oxide. Other drying agents such as sulfuric acid, phosphorus pentoxide, calcium chloride, etc. cannot be used for drying ammonia because these reagents reacts with ammonia. Because of this, only calcium oxide or quicklime is used as the drying agent for this reaction. In industry, ammonia is prepared by the very famous Haber process, in which 1 volume of nitrogen reacts with 3 volumes of hydrogen to give ammonia. The reaction takes place in the presence of iron catalyst. This reaction is a reversible process. Applying Le Chatelier principle, we know that as pressure increases, there is a tendency for the forward reaction to take place. Thus, the reaction takes place in the forward direction at high pressures. The reaction is an exothermic process. So, very high temperature will favor backward reaction. But if the temperature is very low, the reactants cannot acquire the activation energy to form the product. Thus, an optimum temperature of around 450 degree is required for the formation of ammonia. Coming to the physical properties of ammonia, the central atom nitrogen is sp3 hybridized. The 3 hybrid orbitals overlap with the 1s orbital of hydrogens, and the lone pair occupies the 4th sp3 hybrid orbital. The molecule has a deviation from the tetrahedral angle because the lone pair bond pair repulsion is greater than the bond pair repulsion. It has a pyramidal structure with the bond angle 107 degree and NH bond length 101.7 picometer. Ammonia shows anomalous boiling point compared to other hydrides of group 15 because of intermolecular hydrogen bonding. The electronegativity difference between nitrogen and hydrogen makes the NH bond polar, and there is a possibility of intermolecular hydrogen bonding in ammonia. Ammonia is basic in nature. In aqueous solution, it exists as NH4 cation. Ammonia reacts with acids to form ammonium salts. Ammonia plus HCl gives ammonium chloride. Ammonia plus H2SO4 gives ammonium sulfate. As a weak base, ammonia precipitates the hydroxides of many metals from their salt solution. For example, if we treat zinc sulfate with aqueous ammonia, that is ammonium hydroxide, zinc hydroxide, a white precipitate is formed. Similarly, a white gelatinous precipitate of aluminum hydroxide is precipitated when aluminum salts like aluminum chloride is treated with ammonium hydroxide. A brown precipitate of ferric hydroxide is formed when aqueous ammonia reacts with ferric salts. Ammonia reacts with oxygen to give nitric oxide. This is an oxidation reaction. In ammonia, the oxidation state of nitrogen is -3. It changes to +2 in the nitric oxide. When treated with alkali metals, the corresponding amides are formed. Sodium reacts with ammonia to give sodamide or sodium amide. Potassium reacts with ammonia to give potassium amide. Ammonia reacts with Nessler's reagent, that is K2HgI4, in the presence of base to give iodide of Millen's base, which is brown colored. This test is used for the qualitative analysis of ammonium cation. Ammonia reacts with halogens when ammonia is treated with chlorine or bromine in limited amounts. It gives corresponding ammonium salt. When treated with chlorine, we get ammonium chloride and nitrogen. If the halogen is present in excess amounts, it will yield the corresponding halogen acid and NX3. The nitrogen trihalide thus formed is very unstable. When ammonia is treated with iodine, a solid adduct NH3 Ni3 is formed. And if this solid is struck with something, it will explode to produce iodine vapors, nitrogen, and ammonium iodide. Ammonia has a lone pair of electrons and thus it acts as a Lewis base and reacts with BF3 to form NH3BF3. Ammonia forms complex with metal salts. For example, silver chloride when treated with ammonia gives diamine silver 1 chloride. This complex is colorless. So the white precipitate of silver chloride dissolves in ammonia to give diamine silver 1 chloride. Another example for complex formation is the reaction of ammonia with copper salts. An aqueous solution of copper 2 plus salt is pale blue colored. This when treated with ammonium hydroxide gives a pale blue precipitate of copper hydroxide. It will dissolve in excess of ammonia to give deep blue colored solution. And the deep blue color is due to the formation of tetraamine copper 2 cation. Cu2 plus NH4OH gives CuOH twice. It reacts with excess of ammonium hydroxide to give CuNH3 4 times. And the complex has a charge of +2. Ammonia has several applications in industry as well as laboratory. It is used as fertilizers to increase the yield of the crops. Ammonia is used in the household as a cleaner. It is used as an antimicrobial agent. Ammonia is used in fermentation industry. It is used as a refrigerant. It is used to adjust the pH in fermentation process. It is used to neutralize pollutants like nitrogen oxides emitted from diesel engines. Ammonia is used as a fuel for rocket engines. It has several applications in textile industries. It is used for the manufacture of synthetic fibers like rayon, nylon, etc.